Hello, everyone, and welcome to the first class of our Introduction PLC course. I'm Michael Graff. Then we will teach about how to convert electrical diagrams into PLC logic. Then this course was created for electrical industrial electricians that want to understand and learn about how it works the famous PLC. Then I was industrial electrician in the past. Then I created it's a simple method that I put in this notebook, and I hope that you understand too and learn how easy is to work with PLC. Then if you already know, if you already have a basic acknowledgement about control diagrams like DLL starter, forward, reverse DLL starter. This course is made for you. Then I hope that you enjoy this. And let's begin. Then I will use another scene for this. Then how we gonna works our course? Then it was about 6 lessons. Then every lesson we will talk about uh, it's about a team. Then in the lesson one, it's today lesson. We will talk about historic and signals. Then what the industrial revolution that we already beginning this electrical systems. Then control diagrams that we gonna see today's, and about signals, about digital signals and analog signals that we know today that we're gonna see. And in the lesson 2 we will talk about DLL starter, then why we use ladder. This is the question that we're gonna answer in this lesson. And we talk about wiring inputs and outputs. That's an important thing about every lesson. We don't know talk about how it work DLL, because if you already have a basic knowledge about industrial electricity, then I think you already know this. But if you don't have this information yet, you can find some information in the internet. But the important thing about all the lessons, if we gonna understand why automation come from this, because the automation come in the past about the control diagrams. That is why it's so important we know about this. Then every lesson we will talk about a theme directly in the control diagrams of DOL. Then lesson 3, forward and reverse starter, or forward and reverse DOL, that we're gonna motors that can run forward or reverse as a simple control diagram. But in this lesson 3 we will talk about interlocks. It's very important into PLC logic. Interlocks, it's one of the most important things when you wanna go about logic in ladder. This is a very important thing that we gonna see in the lesson 3. Lesson 4, we gonna talk about star delta starter and auto transformer starter. Then in this lesson we must talk about specifically timers, how it works, the time in the PLC. It's more easy, it's more hard. It's a very important thing. It's a greatest thing, in my opinion, that PLC bring us. It's timers controllers. That's not infinite timers, but it's timers enough to create our logics, our little logics. Then this is gonna see in the lesson 4. In lesson 5, we talk about motor pumps alternation with flow switch. It's a control diagram that we use a lot of here in my country. it's a lesson important to we understand how signal replication and signaling works in the PLC. Then why it's so important? This lesson for us. Then in the last lesson, we will talk about advantage of using HMI. Then with this, we're gonna see a little introduction about GA Portal. That's the it will be our next course. Then after these 6 lessons, it's possible to you wanna go understand more about PLC. Then here in my country, I work with TA Portal. It's a Siemens integration system, and all of this it's a base knowledge to we start to think in programmation, start to think in TA Portal. Anyway, it's an important course for this. Then I hope that you enjoy. Don't forget to use your notebook that already possible to download in our platform here, and use the notepad, and don't forget to write your notes. And if you have some questions, don't forget to comment, and if possible I will answer all your questions. All right, then let's begin with about historic. Then it's lesson 1. We're gonna we're gonna see today why is important we talk about historic lesson, because with the story we can understand, is a better way to understand our present here, right? Then if you wanna go back in the 1800s, we have the first industry revolution. That's in industry uh, industrial revolution 1.0. Then it's the first revolution that we have beginning to use steam systems, steam powers, then machining with steams, and introduction to manufacturing. It's uh, it's uh, it's a great revolution that give us about uh, start to think in efficiently and power and steam. Then after this, after the 1900s, we have in Revolution Industrial 2.0. Then this is an important thing in this revolution, as we can see here, electrical power. That's the beginning that we start to use um, commands and control diagrams to turn on our motors. Then with motors turn on and turn off, it's possible to control our manufacturing. With the key switch, it's more easy to a man turn on a machine than I turn on press a button or turn on a switch. Then this is uh, turn on a contactor. That's the beginning of the contactor. And when the contactor is invented, from in my opinion, it's one start this automation, because automation is it's only possible with the indirectly direct starters. Then I have here a contactor, right? Then contactor born in the 1900s, 1929. I think this is 1929. All right. Then with the use of the electrical controls, it's possible to start our machines. It's a safety model, but when we need to change our setup in our industry, or we have to give a manutention, it's if we have a problem, then I must correctly this problem. With the control diagrams, it was really hard to do this. Then after the Second World War, I think in the 60s or 70s years, the industry 3.0 came came for us. Then why this can give us in the past? There is in there is the born of PLC. Then all of the control diagrams that control our manufacturing industries come to a program controller. Then our circuit controllers or control diagrams is like if we virtualize it, this system. What's the advantage for this? When I virtualize it, electrical diagram is a physical way, and it can cut a wide break. Then it's possible that we cannot um, fuse contacts. There's a problem. And when I change these wiring diagrams for PLC, I don't have this problem anymore. If we have to change our setup, change a time, change a way of our automation, I don't need anymore to uh, change wiring. It's come take us very time. We lost very time this process. Then with the PLC, these problems don't have any. We don't have this problem anymore. Then the beginning of use PLC is in 70 years. Is the 70s, right? And now today we have some countries, some industries in this 4.0 industry. In this revolution, we have the IoT things, we have the big data, then all of data of my manufacturing, of my industry, I digitalize it, this information, and bring it to a cloud, and change this information between a lot of the peoples. And my industry now is turning a sensing being thing. It's like with artificial intelligence, it's possibly to I give life to my industry. Then she thinks for me. Then he thinks all this data for problems or process data, and understand. She's understand alone how it the best way to process, to build that that industry must be. That is a it's a industry. That is the local time that we hear now in the industry 4.0. But we already have a lot of industries that use only control diagrams like 2.0 industries. That is why we need to understand today about this curse of PLC, because uh, as we start in the industry 4.0, we have some industries in 2.0. Then we needed to bring us to this. Then I must pick my get all of my wiring diagrams and convert to PLC logic. It's we don't have another way to jump for this. Then this is a natural process that all uh, electrical industrial electricians must know, and this is why we are here to learn in this class about how to convert diagrams. Then let's continue. I apologize for my bad English. I hope that you can understand some things. If you don't understand, pull the jump the video in the next minutes. Then I think it's possible to understand something. But I promise that we will get better in this. And I'm starting now, then apologize by my bad English. But I think this is good enough to all of you understand this, all right? Right here, we have a control diagram. This is a simple, very easy control diagram that we have some normally opens, that we have a button, start button, and we have a stop, K1. K1 is a contactor. Then we have here F1. This contact with the symbol is meaning about overload. Then it if you gonna see this start button and K1, I have the seal of the contact. Then when we push this button, K1 turns on. When K1 turns on, this normally open contact, hey, close it. Then my motor, it's possible that the motor here, it's turned on. Then you stay in this state. When I put the stop button or K0, I'm, I think it's a sensor with the limit switch. It's turned on, it's interrupts my K on, that's turned off. And with my K1 coming for overload, then open here, then turn off too. All right, I don't know, talk about how this control diagram works, but what is the important thing that we gonna think now? When I have control diagram, if we have a problem here, I need uh, to measure our points electrically, and I need to get my multimeter and put in neutral here below, and I want, and the other point, let's color here, then I put one in neutral, and the other point I put this, and I will gonna measure every line, every barn, every contact that we have here. This take a long time to we understand what's the problem that we have here. It's one problem. We have another problem. Think about, we need to change this logic. Then I need to put some new sensor here. Then I want to bring my tools. Then I cut this wiring and put another clips. Then connects to another sensor, another condition in the circuit. And after I do this, I must update my control diagram, because it's important thing to next to electricians, it's came for to solve a problem. He must give we must give him update circuit to he can understand and solve another problem that can appears in the future. Then it's like I say in the beginning, when we have control diagrams, every time that I have an electrical problem or I have to change my logic, I need to come here in the machine and change my wiring physically. That is the greatest advantage that we can bring in the PLC, use of PLC. Because when I have the PLC, I get all of these signals, then I put in my PLC, then I process the logic, and every time that I work in the problem to solve a problem or change my logic, it's really, really more easy. That is the principle of our course. Why we can get this and put in a PLC. How many inputs, how many outputs we needed. That is why we are here. That is why I telling, and I hope to telling you about how we do this. All right. about signals. When we talk about signals, in my country, it's called sinais. I'm from Brazil, then we talk Portuguese here. Then I always forget it's in English. I it's called signals or signals. But anyway, we have here a PLC S7 1200. It is a PLC that we use here. Like I say in the beginning, I'm a Siemens integrator. Then I work with TA Portal about 5 years, 6 years. I don't remember now. But we use him to we understand our the new concept that we talk about here. All right, my PLC works in the simple way to understand in 3 cycles. We call this is a read of inputs program, execute program, and write outputs. Then every PLC works in this way. I read all of my inputs, then I process these inputs in a program, then I write my outputs, then I do something in the field, and then I read the inputs again, and this cyclical occurs in infinite way. This is the simplest functionally of PLC. Of course, there is another. I forget this word. Another functionalist of PLC that we gonna see specifically in the other course. For now, think about only this scan cycle that we can talk here. It's the main cycle behind PLC or about his functions. Then what is input or outputs, or why or how we can understand our signals here. That is why we think about digital signals and analog signals. But what is a digital signal? For us understand this principle, I create this. It's a simple diagram. If you already electrician, it's go easy to understand. Let's put here is the eyes or digital inputs, but what is a digital input? It's very simply to explain this with this circuit here. Then think about, we have a simple circuit that I have source here. It's a symbol for AC, but it can be a DC source here. Then we have a lamp, a simple lamp, and we have a switch. When I come here and close the switch, what happens? It's very simple. My lamp turns on. Then, if we come here and turn off the switch, my lamp is off. The discrete signal, or for PLC digital signal, or for us digital input, it's every signal that only have 2 possible states. What's the possible states we can have here? Or I have the lamps turn on or turn off. My lamp cannot stay in the between position in turn on or turn off. It's impossible to this. My contact, my electrical contact, only have these 2 possibilities. Or it's closed or it's open. Then when it's closed, my lamp turn on. Then when it's open, my lamp is turn off. Then we have only 2 states. Always remember to think about 2 states. Digital inputs, it's a signal that have only two states that can be 0 or 1, like in our image here. It can false or true. It can be 1 or 0, turn on or turn off. Anyway, digital inputs, it's our anything, any any equipment that only two states. I put some of this right here. Then, like any one of this, it's we can widen like digital input. Then my butt, it's an example for this. I have the push the button, it's turn on, and when I push, it's turn off. It will depends of the context. It's normally open or normally closed, but in the way it's only two possible states. Then my limit switch or level switch, it's the same thing. Or I have level or I do not. Then my sensor here, it's the same thing. Or he is detecting something or not. My emergency button is the same way. Or is pressed or not. Cannot be a 50% pressed, not. It's or fully pressed or not. My limit switch here, it's the same thing. Then all of these things that we are seeing in this video, in the image here, it's digital inputs. That is why we can call this digital inputs or the eyes. Here is an important thing for us. This kind of signal is the most, it's the basic signal that we gonna work, because our control diagrams, uh, they have a lot of digital things. Think about every contact here. All of these actuators and switches and sensors and contacts, everything that we have in this wiring diagram, it's we can understand like a digital kind signal. It's simple to see here. That is why the digital signal, it's the most signal that we gonna works. In my PLC, I wanna it's a symbolic way I will widen my sensors here. Please do not bring it to a serious thing. It's only for demonstration. In the next video, we will talk about how we can widen exactly digital input. But in the SF1200 here, this part here and below, upside of the PLC, that is the place that we wiring our digital inputs. Then after the DIs or digital inputs, we gonna have to the analog signals. Then how it works, how this thing it works, it's simple to think, but it's more complex to wiring this type of signal, because he is limited about the kind of the physical measure that we can talk here. Think about every kind of measure that we have in the environment, or physically, like temperature, pressure, speed. Think about in a single day. We have a lot of temperatures in the day. In the morning, we have temperature. I put here about 10 degrees. In my country, it's common because I live in Brazil. That's a tropical weather here. Then in the morning we have it's possible to have 10 degrees. Then after the midday we have 15 degrees. And after afternoon, it's calm down. It's going down to 9 degrees. By the way, analog signal, it can have a lot of possibilities, a lot of states. It's not only true or false. It's not only 1 or 0. It can, in the trend here, -1 after 2.5, 3.43, 4.93, then after comes down 4.01. Anyway, it's a lot of possibilities. Then think about every type of measure that you can have in your car, in your house. It's possibly like in my example here, I draw a lamp circuit. It's possible to think about this, but with another tools. Then I already AC source here. Then think about we have a potentiometer or a dimmer. Then the same lamp, same voltage here. Then with my potentiometer, I can put in the position of like 25%. Then my voltage here in the lamp, it's about 25%. Then the power of the lamp can change in the same way that I change the value of my potentiometer. This is an analog signal. Then in the first example, my lamp it's turn on or turn off. It cannot take a place between this. But here it's possible. So my lamp, it's low bright in 25%. Then I greater this, I up this for a 45, then after 65, then after I in the same way that I upside or percent here, my right of the lamp it's up or down in the same way that I change my potentiometer. That is why we can call this analog signal, because it can take a lot of states, not like the digital that's 0 or 1, but a lot of states, a lot of values. Then my AI's analog inputs, then I put some examples here. Then we have transmitter, pressure transmitter. I have a PT100. It's a temperature measure. Then I have a potentiometer. These AIs we can shoot them to wiring in my PLC. That's I will do now. That's wiring in my AI inputs. Then we have only these two type of signals: AI analog inputs and DI digital inputs. But these input signals, the digital signals or analog signals, it's possible to see them in the outputs of PLC. As I say, first we read of these inputs, then I understand why what of these inputs it's pressured or not, it's in true value or false value, or it's a between value, the way of the analog input works. Then I execute my program and I write outputs. Then my outputs also wanna be signals. Then we have two type of output signals. We have digital outputs and analog outputs. What this, how I can see this? Then think about anything that any two possible states, I put here a contactor. My contactor here, uh, it can stay only in two states, or my contactor's pressured, it's turned on, or it's not pressured, it's turned off. My contactor do not have position between turn on or turn off. Then it's a digital output. It's an example, or we can understand my three-phase motors. It's the principal motors in our control diagrams. As I say in the beginning, DLL starters, forward reverse starter, star delta starter. All of this is turned on by contactors. Then my contactors, we can wiring in my PLC by DL or digital outputs. Another type of digital outputs that we can use, it's two solenoid valves. Then my solenoid valves, it's for turn on our pneumatic actuators. Then it's possible with the air. Change my position here. Then I put the DL for a solenoid valve. It's about 25 volts DC. And when I turn on this valve, he put a mechanical here, then my air, the pneumatic actuator here, then it's put to going to forward or going to back. It's possible to do this. It's very simple. And another type of DL or digital outputs, it's about signaling. Then it's possible to wiring a lamp to indicate something for the operator panel for our operators, and sound beacons. It's possible when I can take the attention of the operator. I put the digital output this, and he can hear about the alarm or about a condition in my process. It's possible to do this already. Then after DL digital outputs, we can already have the analog outputs. Then with analog outputs, in the same way that we see in the analog inputs, it's possible with analog outputs, we can control some things like a control valve. In my control valve, for example, I need to get a set point for a controller that I like the PAD controller. Then I need to open a control valve, steam control valve, to upward my temperature. Then it's possible to put in the valve 45% of openness. Then I open 45 mechanical, 45%. Then I put steam in my control. Then if my temperature do not get in the set point, my controller it's open and open over and over, then 45, then after it's possible to 55 and 65. It's opening every more than to get the set point. Or the other way, it's the true also, then I need to not so highness temperature, then he closed my valve. It's possible to do this. We have it's possible to control three-phase motors when VFDs, then variable frequency drivers. Then today we use a lot of VFD in network. It's more easy to control and get data from VFD. It's more easy, but it's possible to use analog outputs and wiring to put analog signal here. Then I forgot to talk about the signals. It's possible to be a signal in 0 or 10 volts or 4 to 20 milliamperes. It's the sinus that we work in the industry. Then wiring analog output for my VFD is possible to control the speed of my motor. Then the same way in the control valve with 50% and 65% or 100% anyway. Then it's possible to use my signaling to put an analog value in the display that will show me about the current of a motor or the speed of a motor or openness of a valve, anyone. It's possible with analog outputs to point in the indicator here, and we can see a proportional value come from of PLC. Then in the overview here, we have all these things wiring in our PLCs. It's a it's a good view to understand because all of this we gonna wiring in my PLC, but the process and all of the logic is we gonna inside of them. Then it's more easy to view. All of these inputs come here. Then my PLC process in the program this information and use this information in the program and write outputs, then control something in the field or signaling or anyone. Then this is a way to understand how PLC works. Then this is our first class. This is the first class. I hope that you enjoyed this class. Don't forget to see the next videos, and don't forget to use your notebook and notepad to give notes of how I'm talking to you. Once again, I apologize for my bad English, but I promise that we're gonna be better in the next videos. Then I hope see everyone in the next class. And I say goodbye for everyone and see you next video.